Expected value and variance. So the downside, I guess, of this is that when we're not making lists and using our lists in order to calculate things, we can't really find our expected value and our standard deviation or our variance in the same way. So we now actually have a formula for these, excuse me, but they are all in the formula packet. So I remember when you guys got confused about variance in previous tests, you could see that there was a variance formula in your formula packet, but you didn't really know how to use it, and it's because it was for something else. So your expected value, which is mu or E of x, is equal to n times p. Remember that n is the number of trials. And P is the probability of that thing that you're looking at. So this is your formula. It's in your formula packet, and it makes sense that your expected value would just be the number of trials that you're doing times the probability of that thing occurring, right? If we had 100 laptops, and we wanted to find the expected value of defective laptops, it would be 10% or 0.1 times 100, which is 10, right? There should be no other reason why the expected value isn't 10 when we're talking about 100 laptops. So that's all it is you've just taken the number of trials and multiplied it by the probability and saying, that's how many I expect for there to be in this situation. Variance is slightly different to it. Remember that it's your standard deviation squared. So most of the time you'll see in these later examples, we're asking for standard deviation. Although I don't think this guy asked for standard deviation, but it is in later ones. So you just find your variance and then square root it. That is equal to your number of trials times the probability of that occurring times the probability of that not occurring. Your textbook labels it as Q, but your formula packet does 1 minus P, and then your textbook says that Q is 1 minus P. I just think it's confusing, so we'll just stick with what your formula packet says. 1 minus P is the probability of that thing not occurring, and that's how you find the variance. To find the standard deviation is you square root it. Okay, let's do one more example to practice. A study to examine the effectiveness of advertising on the internet reported that 4 out of 10 surfers remember advertisement banners after they have seen them. 20 surfers are chosen at random and shown an advertisement. What is the expected number of surfers that will remember the advertisement? This is, if you just take a step back and think about it, just logical. If you are looking at 20 surfers and the probability that 4 out of 10 of them remember, you just kind of multiply that out together. If n is equal to 20 and your probability is 0.4 or 4 out of 10, if we're looking out of 20, go ahead and tell me what that is. Sorry, my answer key says 5, and I have no idea why. So I'll change it because I was like, obviously that's 8. 8 surfers, because mu, or the expected value, is just equal to n times p, 20 times 0.4. Okay, what is the chance that 5 of those 20 will remember the advertisement? And this is, yeah, so then now maybe that's why I wrote 5. So now what we're looking at is the probability that 5 out of the 20 will remember. So we're talking about this calculation that we've been doing in our calculator, where n is 20, p is the probability that they will remember, which is 0.4. And then the x value is the number of outcomes that we want, which is 5. Go ahead and plug that into your calculator. Remember, you hit menu 5, 5A. or just look at it, we're looking at probability, and then we're looking at distribution, and then we want a binomial distribution. When we put these all into their appropriate places, what we should get is that the probability of x equals 5 is equal to 0.0746. Okay. The probability that at most one surfer would remember the advertisement. So, okay, again, this is like tricky with the language thing. Take a step back and say, okay, does 0 satisfy this? Does 2 satisfy this? Would 0 satisfy that it was at most one surfer? Yes. If you had 0, you're still not above one surfer. Versus if you had 2, that would be more than one surfer, so that wouldn't satisfy what we're talking about here. So always taking a step back and throwing some numbers to fully understand is a great strategy. So that means I'm looking at the probability that my outcome is less than or equal to 1, which is really just the probability of 0 or the probability of 1. You can go ahead and go in and find these and type them out into your probability distribution, but I do want to show you where potentially not using your X value would be helpful. So if you go menu 5.5a and we put 20 and then we put 0.4, and then we just press enter, it gives us that list that I was talking about. It's in crazy scientific notation, but this is the probability of 0 and this is the probability of 1. And so I already have both of them done for me right now, so I don't have to go back in and recalculate them. So e -5, remember that means I'm moving my decimal 5 times to the left, which means I'm going to have 4 zeros in front. 1, 2, 3, 4, 366. Plus the probability of 1 is the next one then. It's e to the -4. Which means I'm moving this decimal 4 times, which means I'll have 3 zeros. 487. Oops. We add them together and we get 0.00, oops, 0, 5, 2, 4. So you could have just typed in the 0 for the X value and then the 1 for the X value and then add those things together. That was what you saw in my calculator at the very beginning of class. But you could also then just use that whole list if you don't want to retype it out. But so that's just the benefit of not using that optional X value. What is the chance that at least 2 surfers would remember the advertisement? At least 2 surfers means that we could have 2, 3, 4, 5, 6. So the probability that your outcome is greater than or equal to 2 is the probability of 2 plus the probability of 3 plus the probability of 4 plus, we're talking about 20 trials here. So that's going all the way up to the probability of 20. That list that we just got, that I just got on my calculator is massive. It's really long, and I don't want to go in and write out 18 different probabilities. So we can work smarter here and not harder. And what we could do instead is that we know that the only 2 probabilities missing out of here are 0 and 1. And we know that all of these probabilities must add up to 1. They must add up to 1, which means if I wanted to find out what this is, I could just say 1 minus, and then the probabilities that aren't here, which there are only 2. The probability of 0 and the probability of 1. Which, hey, we just found up above. Go ahead and calculate that for me. You should have gotten 0.999476. So a very close to 1 number. But that's how we calculate it, trying to work smarter here. So if you ever realize, like, building out this visualization of like, oh, okay, well, that means 2 plus 3 plus 4. Oh no, that's a lot that I have to add up. So try and think about, oh, okay, well, I could make this easier on myself and just subtract from 1 is a strategy, because I don't want you to be spending that much time on a test on something that you could just do really quickly. Okay, great job today.